Hi guys, welcome back to my channel. Before we start with our new math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. Just hit on teacher dong. Okay, so today we're going to have angles formed by secants and tangents. So in the previous lesson, we were able to discuss inscribe angles, and prior to that, we had the introduction about circles and the central angles. This time, let's talk about the angles formed by secants and tangents. So it could be two secants intersecting in or out, and then tangents or combination of secant and tangent. So for my students and for your reference, you can check on your books from page 187 to 197. Okay, so let's define first if what are secant lines. Okay, so in the first lesson about circles, we're able to define secant line. Let's have a review of it. So secant lines are lines intersecting the circle at exactly 2 points. So just like what you are seeing in the illustration, see there are two secant lines. Okay, so when we say secant lines or secant line, it passes through the circle at exactly 1 point. So that's it. Let's have tangent lines. Tangent lines are lines intersecting the circle at exactly 1 point. If a second line touches a circle or passes through the circle at exactly two distinct points, here when I say tangent line, it only touches the circle at exactly 1 point. So it means that point of intersection or point of contact is on the circle or circumference of the circle. Now, let's talk about the theorems that involve secants and tangents forming angles. Okay, so the first one is Theorem 113, or the intersecting secants exterior theorem. So what you need to remember about this is the word exterior, because the angle formed is located outside the circle, or at the exterior of the circle. Okay, now Theorem 113, the intersecting secants exterior theorem, says that the measure of an angle formed by two secants that intersect in the exterior of a circle is one half the difference of its intersected arcs. So just like what you are seeing here, this is the angle formed by the two secants. Okay? So this one, arc BC is what we call the far arc, and arc DE is what we call the near arc. So to solve for the measurement of the angle, measurement of the angle A is equal to 1 half. This is constant or default. Quantity, the measurement of arc BC. Arc BC here is the far arc. So just remember that since you are subtracting, you have to subtract the bigger or the far arc and the near arc. So far arc minus the near arc, which is arc DE. Okay, that's it. Now, if you're going to ask me, are we only solving for angles? No. Sometimes you need to solve for the far arc or the near arc. So, we will just be using the same formula or equation for that. Alright, so just remember 113, the intersecting secants exterior, that the angle is located at the exterior part or outside the circle. Next, example number 1, solve for the value of x. So solve for the value of x. Value of x is angle A, which is the angle formed by two secants. Okay? So arc C is what we call the far arc, and it measures 160 degrees, and then BD is the near arc, which measures 60 degrees. So before we can solve for the value of x, we have to form first our equation. But please don't forget to analyze first the diagram before you go ahead with your solution. Alright, so it's now measurement of angle A equals 1 half quantity the measurement of the far arc, which is arc CE, minus the measurement of the near arc, which is arc BD. Okay, and then after that, we will substitute the given values. Since the measurement of angle A is x, okay, we will just be writing x here. Then after that equals 1 half quantity the measurement of arc CE, which is 160 degrees, minus the measurement of the near arc or arc BD, which is 60 degrees. And then after that, okay, it is equal to 1 half, then subtract 160 degrees minus 60 degrees is 100 degrees. Then finally, half of 100 degrees is 50 degrees. So this is now the value of x, or the measurement of the angle formed. Alright? So that's the step-by-step process. First, you have to analyze the given diagram or the illustration, and then after that, you have to form your equation using the theorem. Here, we use Theorem 113. 13. Okay, next, let's have example number 2. Solve for the value of x. So x here is not the angle, rather it is the near arc. So near arc is missing, the far arc is given, and the angle is also given, the angle formed. So the first thing is we have to form our equation. The measurement of angle A is equal to 1/2 times the far arc, which is arc RM, minus the near arc, which is arc EL. Okay, then after that, substitute the given values, wherein the measurement of angle A is 36 degrees, equals 1/2 quantity measurement of arc RM, which is 100 degrees, minus measurement of arc EL, or x, or the unknown. Then after that, we have to multiply both sides by 2 so that we can remove the denominator of 2 in the right side of the equation. So we will do that. Multiply both sides by 2. Why 2? Because the denominator is 2. To remove 2, we have to multiply 2 on both sides. We cannot only multiply on the right side because it's an equation. We have to make both sides equal. What we do in the other side, we have to do it also in the other side. So we will cancel 2 here, and then 2 times 36 is 72 degrees, equals 100 degrees minus x. Then we need to isolate negative x by removing 100 degrees here using the addition property of equality. Opposite of 100 is negative 100 degrees, plus or positive 72 degrees equals negative x. Okay, and then we will perform the addition. Negative 100 plus 72 is negative 28. So negative 28 is equal to negative x. We cannot have a negative degree measure, so we will divide both sides by negative 1. So therefore, negative 28 divided by negative 1, since they are both positive, it will become positive 28 degrees. So this is now the measurement of the far arc, or the value of, or no, the near arc, or the value of x. Okay? So if you have questions and clarification, please don't. You can comment down below, and for my students, you can send me a personal message regarding this. Next, example number 3. Solve for the value of x. In this case, it involves algebraic expressions. So this is just very easy. We will just be applying some algebraic techniques following the equation for Theorem 113, and everything is okay. Now, we are just solving for the value of x. First, we have to form your equation. Measurement of angle U is equal to 1/2 quantity the far arc, measurement of the far arc, which is CE, minus the measurement of the near arc, which is arc RD. And then we will substitute now the values. Measurement of angle U is x over 2 equals 1/2. Okay, quantity the measurement of the far arc, which is x plus 80 degrees, minus the measurement of the near arc, which is x plus 40 degrees. Then we will simplify, and then since we have denominators in both sides, we will be removing it by multiplying 2. So this will be cancelled, and then this will be also cancelled. So therefore, x is equal to x plus 80, and then distribute negative in the binomial. So negative x minus 40. Then after that, combine the similar terms. So x minus x is 0. Okay, we don't have any more answer for that. Then 80 degrees minus 40 degrees is 40 degrees. So 40 degrees now is already the value of x. So 40 degrees is neither the measurement of arc CE, measurement of arc RD, or nor the measurement of angle U. So if you would like to solve for the measurement of the far arc, just substitute x, which is 40. 40 plus 80 is 120 degrees. It goes like that. Alright? Now, let's have example number 4. Solve for the value of x. Still, we are solving for the value of x. The initial step is you have to analyze the diagram. Then after that, you have to check if what is the theorem that you're going to use. So in this case, we are still using Theorem 113, or the intersecting secants exterior theorem. Now, form your equation. Measurement of angle R is equal to 1/2 times the measurement of the far arc, which is CL, minus arc, or measurement of arc AL, or the near arc. Then after that, we will be substituting the values. Measurement of angle R is x plus 3 equals 1 half times the far arc, which is 4x plus 8, minus the near arc, which is 50 degrees. So we will now be solving for the value of x. Okay, so but before we proceed, we have to remove the denominator by multiplying both sides by 2. So this will be cancelled. Then distribute 2 in the binomial. So 2 times x is 2x plus 6 equals, okay, so this was already cancelled, 4x plus 8 minus 50. Then after that, we will simplify and combine similar terms. Okay, so 2x, it is similar to 4x. Get the opposite of 4x here, which is negative 4x plus 2x. And then we have 8 minus 50. Opposite of 6 is negative 6. Then we will combine negative 4x plus 2x is negative 2x equals 8 minus 50 is negative 42, and then negative 42 minus 6 is negative 48. Okay? And then after that, divide both sides by negative 2 to get the value of x. Alright, so this will be cancelled. And then x equals negative 48 divided by negative 2 is positive 24 degrees. So that is the value of x. It's 24 degrees. Next, let's talk about Theorem 114, tangent point secant theorem. So tangent point secant theorem, don't worry, this is very easy because it's just similar with Theorem 97, inscribed angle theorem, or inscribed angles theorem. So Theorem 114, we call it tangent point secant theorem. So we are talking about tangent point and a secant. Okay, so the intersection of tangent and the secant on the circumference of the circle. Okay, so the measure of an angle formed by a tangent and a secant drawn at the point of contact or point of tangency is 1/2 the measure of its intercepted arc. So you can see that in circle O with line BC as the tangent, this one, and then intersecting secant line AB at point B. So if we have this one, we have angle formed ABC, and then we also have the other angle at the other side. So if you would like to solve for this angle here, angle ABC, just simply multiply the arc measure by 1/2. So it's just the same as Theorem 97. And here, you need to multiply this arc by 1/2 to get the measurement of this angle. So we can say that the measurement of angle ABC is 1/2 the measurement of arc AB. Teacher, what if we are looking for the arc measure? So same thing. If you are solving for the angle, you are going to multiply 1/2. When you solve for the arc, you will multiply by 2. You will multiply the angle measure by 2. Okay, so let's say this is 240 degrees. So if this is for 240 degrees times 1/2, it's just 120 degrees. So if you are solving for the arc, it's 120 degrees times 2, it will become 240 degrees. It goes like that. So the angle formed is at the point of contact of a tangent and a secant. Example 5, solve for the value of angle 1. So if you would like to solve for the value of angle 1, which is in the illustration, locate its arc. So this is the arc. Just simply multiply 1/2 times 270 degrees. So 1/2 of 270 degrees is 135 degrees. That's it already, the measurement of angle 1. As simple as that. Next, let's solve for the measurement of angle 1 here. So this is its arc. Okay, there's no measurement, teacher. What are we going to do? So as you can see, this is a semicircle arc. So a semicircle measures 180 degrees. So therefore, to solve for the measurement of angle 1, you will have to multiply 1/2 of 180 degrees. So 1/2 of 180 degrees is 90 degrees. So the measurement of this angle is 90 degrees and its arc is 180 degrees. So that is Theorem 114. Okay, so this theorem is very easy. Alright, let's talk about the last theorem for today, Theorem 115, intersecting secants interior theorem. If in Theorem 113, don't be confused, we are talking about the exterior angle formed. In this case, we're going to talk about the angle formed inside the circle, or at the interior of the circle. Okay, in the interior of the circle. Alright, So let's define Theorem 115. The intersecting secants interior theorem says that the measure of an angle formed by two secants that intersect in the interior of the circle is one half the sum of its intercepted arcs. Okay, so as you can see in the illustration, the angle formed is inside, so it's angle DBP. So to solve for angle DBP, when you need the two arcs. Okay, so angle DBP is also congruent to this angle because they are vertical angles. So if you are solving for the measurement of angle DBP, just remember to multiply 1/2 times the measurement of arc BD, which is the intercepted arc, plus the measurement of arc AC. In this case, we're going to add, since the angle is inside the circle. A while ago in Theorem 113, we are subtracting the far and near. So in this case, we don't have the far and near. Okay, so since it's an addition, it's up to you which arc are you going to write first. Alright? Again, to solve for the measurement of the angle formed in the interior of the circle, just simply multiply 1/2 times the measurement of the sum of the measurements of the two arcs. Okay? That's it. Let's have example number 7. If the measurement of arc BN is 60 degrees and the measurement of arc AR is 70 degrees, find the measurement of BDN. So this is angle BDN. We will be solving for this. So this is the first arc, this is the other arc. Okay, so measurement of arc BN according to the given is 60 degrees and here it's 70 degrees. So you form your equation, the measurement of angle BDN is equal to 1/2. This time we are adding. Okay, 1/2 times the measurement of arc BN plus the measurement of arc AR. Then after that, we will substitute the values. 1/2 times the measurement of arc BN, which is 60 degrees, plus the measurement of arc RA or AR, which is 70 degrees. Then after that, 60 plus 70 degrees is 130 degrees. 60 plus 70, 130 degrees. And then get the half of it. So 1/2 times 65, it's 1/2 times 130 degrees, it's 65 degrees. So the measurement of the angle is 65 degrees. If the measurement of this angle is 65, so this is their vertical angles, this also measures 65 degrees. As simple as that. If in Theorem 113 we are subtracting the far and near, here we are going to add the intercepted arcs. Okay, next. Still example number 7. If the measurement of arc NBA is equal to 260 degrees, NBA, where's NBA? This one. So it measures 260 degrees. And the measurement of arc BR is 80 degrees. So this is 80 degrees. So this one is 260 degrees. And we need to find the measurement of angle ADN. So if that's the case, we need this arc also. For us to solve for this arc, we have to solve first for, of course, NA. So remember that the degree measure of a circle is 360 degrees. So if you would like to solve for this one, you will subtract 360 degrees minus the other given, which is 260 degrees. So 360 degrees minus 260 degrees is 100 degrees. Okay, now, since we are able to have the measurement of this, we can now solve for the measurement of arc angle ADN. So it's now 1/2 times the measurement of arc BR, which is 80 degrees, plus the measurement of arc AN, which is 100 degrees. Okay, so 80 plus 100 degrees is 180 degrees. 1/2 times 180 degrees. So the final answer here is 90 degrees. So the measurement of this angle is 90 degrees. This also measures 90 degrees. Okay. Next, let's have the next example. Example number 8. Find the value of x and y. So for us to find the value of x and y, we have to analyze first the given diagram. So this is the x, and then we have the two intercepted arcs to solve for it. Just remember that when you are solving, you need two given measurements, and then you must only have one unknown measure. So in this case, to solve for the measurement of angle x, we need to use theorem 115, the intersecting secants interior theorem. Okay, interior because the angle is in the interior. So we have now x, or angle x, equals 1/2 the measurements of the plus times the measurement of the sum of the measurements of the two arcs. So it's 50 degrees, this one, plus 70 degrees, this one. Okay, so it's now 1/2 times 50 plus 70 is 120 degrees. Then after that, 1/2 of 120 degrees is 60 degrees. So the measurement of x is 60 degrees. This is also 60 degrees. Now to solve for the measurement of y, okay, so this is y. As you can see, it's at the exterior part of the circle. We are going to use now Theorem 113, the intersecting secants exterior theorem, because the angle is at the exterior of the circle. Now, to solve for it, we need this arc and we also need this arc. So 50 degrees for the far arc and the near arc is 24 degrees. So it's now y. So this time we will perform subtraction. Y equals 1/2 times the measurement of the far arc, which is 50 degrees, minus the measurement of the near arc, which is 24 degrees. So 50 minus 24 degrees is 26 degrees. So 50 minus 24 is 26 degrees. Half of 26 is 13 degrees. So the measurement of y is 13 degrees. Okay? So the value of x is 60 degrees and the value of y is 13 degrees. Just simply identify which theorem are you going to use before you solve. Alright, so let's proceed to example number 9. Find the value of arc AL and the value of arc AS. So let's start first with the arc AL. This one is arc AL. So we have to locate which measurements are we going to use. We have 120 degrees and we have 84 degrees. So to solve for the value of arc AL, we will be using Theorem 115 because the angle is located inside the circle. So arc AL is unknown. So we will have to form our equation wherein the angle measures 120 degrees equals 1/2. So this is addition. So the measurement of arc AL, which is unknown, plus the measurement of the other arc, which is 84 degrees. Okay, then bring down 120 degrees. Before we do that, we have to remove first 1/2. Okay, sorry for that. We have to multiply both sides of the equation by 2. So we will cancel 2 here. So 2 times 120 degrees is 240 degrees equals measurement of arc AL plus 84 degrees. And then, okay, we have to isolate arc AL here is 240 degrees now minus minus 84. Opposite of positive 84 is negative 84 equals measurement of arc AL. So we will now subtract 240 degrees minus 84. So the answer is 156 degrees. So the measurement of arc AL is 156 degrees. 156 degrees. Then next, since we already have the measurement of arc AL, we can proceed now in solving for arc AS. So to solve for arc AS, we have the far arc and then we have the near arc and then we have the exterior angle. So we have to use here Theorem 113. The intersecting secants interior theorem. Even though the other one is a tangent, but we can see that the angle is located outside the circle. So the angle formed is 38 degrees equals 1/2. This time it is subtraction times the far arc, which is 156 degrees, minus the near arc, which is unknown. Then after that, we will remove 2 by multiplying both sides by 2. So this will be cancelled. 2 times 38 is 76 degrees. And then what will remain in this side, we have 156 degrees minus the measurement of arc AS. Then combine the similar terms. Opposite of 156 is negative 156. plus 76, bring down, and then negative measurement of arc AS. So, negative 156 plus 76 is 80 degrees, or negative 80. So, negative 80 degrees equals negative measurement of arc AS. So, to finally get the answer, divide both sides by negative 1. So, measurement of arc AS is equal to 80 degrees. So, this is 80 degrees. Okay? So, we applied Theorem 115 in solving for arc AL, and then we applied Theorem 113 in solving for arc AS. Okay? Analyze first the given illustration. Now, let's have this problem. Two large yachts are heading the island station at two opposite directions as in the illustration. Letter A, if the arc measures 254 degrees, what is the measurement of the near arc? Then for letter B, if the near arc measures 148 degrees, what is the measurement of the angle formed on the island station? Let's start first with A. With A, if the measurement of the far arc is 254 degrees, okay, what is the measurement of its near arc? So near arc is unknown. So just remember that the degree measure of a circle is 360 degrees. We don't need to use theorem here, rather, we will just subtract. So to solve for the near arc, it is now 360 degrees minus 254 degrees. So we will just subtract that. 360 degrees minus 254 is 106. So this is the answer in letter A. So the near arc measures 106 degrees. Now let's proceed to letter B. Before that, let's erase first. Okay, so just remember, analyze first the given illustration before you proceed in solving. For letter B, if the near arc measures 148 degrees, this one is 148 degrees, what is the measurement of the angle formed? So this is the angle formed, but we only have one measurement, but we cannot actually solve for the angle formed with one measurement, so that's why we need this. So just remember that the degree measure of the circle is 360 degrees. If there's an arc missing, just subtract. So in this case, the far arc is missing, so we will subtract 360 degrees minus 148 degrees. So 360 degrees minus 148 degrees is 212 degrees. So the measurement of the far arc is 212 degrees. So we can now proceed in solving for the angle formed. So for the angle formed is 1/2 times it, since we will be using Theorem 113 because the angle is at the exterior of the circle, times the far arc, which is 212 degrees minus 148 degrees. So subtract 212 minus 148 is 64. So it's now 1/2 times 64 degrees. So 1/2 of 64 is 32 degrees. So the measurement of the angle formed is 32 degrees. That's how you solve for problems involving angles formed by secants and tangents. So I hope that you learned from our discussion for today. So if you have questions and clarifications, don't forget to comment down, and for my students, you can send me a personal message. So for my students, you please answer this activity. Hey, so thank you so much for listening, and then I would like to send also my gratitude to those who are supporting and always watching my videos. So please don't forget to hit the subscribe button and the notification bell. It's Teacher Dong. Have a nice day.